In the upcoming series of videos, you'll learn how to add new elements and attributes to your database. The elements will be the representations of your assets, and their accompanying attributes will hold the data associated with those assets. So let's look at a completed database, just to see how this might look. Here's my completed HVAC database, and you can see I have elements for my 3 different types of equipment, my blowers, chillers, and heaters, and they each have their accompanying set of attributes. For example, we can have attributes that hold PyTag data, or static metadata that's either manually entered or found from a table lookup, and we can have calculated data that combines values from other attributes to provide a calculated value. Now, elements don't necessarily have to be direct representations of equipment. They can also represent organizational units. For example, here we have 3 zone elements to organize our HVAC equipment, and a top-level facility element that organizes all the zones. And of course, each of these elements can have their own set of attributes. For example, here we have a roll-up attribute that's calculating all of the energy consumed by all of the equipment within the research lab. So let's move forward and see how you can start adding elements to your own database and adding attributes to those elements to hold the data for your equipment. Starting with our new empty database, I'd like to begin modeling our HVAC system. First, I'll start by adding a new element to represent Zone 1. To create a new element, I can use this New Element link in the Viewer area, or I can right-click on the Elements collection in the Browser area and select New Element. It'll ask me which template I want to use. Since we currently don't have any templates, I'll just stick with the default of none and choose OK. And you can see that my first new element has been created. It's by default labeled as Element 1. If I were to create another element in the same manner, it would be called Element 2. AF will naturally number new elements sequentially. Now in this case I only need one element to model Zone 1. So if I want to get rid of Element 2, since you can see here by these red check marks, these 2 elements are checked out to me. And if I want to undo something I've done while I have items checked out from the database, I can use this Undo All Changes to the Database button. And here you'll see it'll show me all changes to the database since the last time I checked in. Now I'd only like to undo the addition of element 2, so I'll leave that one checked and uncheck the addition of element 1 and undo checkout. And now you can see element 2 has been removed and I'm back to only element 1. Now looking at the viewer area for element 1, you can see that I have multiple fields that I can fill in. I'll start with the name and call this element Zone 1. I can also add a description, so I'll add all the parts of our research lab that are covered in Zone 1. Lab A, Lab B, Lab D, and the warehouse. Now if I were basing this on a template, that name would show up here. Also, if I had selected any or created any categories for these zones, I could add them to the element. Next, you'll see these tabs across the top that give me more information about the element. I can see any child elements of this parent element. The attributes, this is where we're going to be adding our data items going forward. Ports, which we won't really worry about. Analyses, to add calculations to an element. And finally the version tab, where if we end up doing versioning for a particular element, the details of the versioning would show up here. All these will be discussed later in the course. The next thing we'd be interested in is adding attributes, and that's where the next few videos will be going. For now, I'm going to go ahead and check in my work, and we'll keep Zone 1 in our database. Now that we have our new element, we need to add some attributes so that we can start mapping data to this element. To start with, I'll define a generic attribute and discuss the various fields that we use to define an attribute. Starting with a blank viewer with no attributes, we can choose the new attribute link here to create a new attribute, or at any time we can right-click in the viewer and select New Attribute. You'll see a new attribute is created with the generic name attribute 1, and again, as with element creation, new attributes will be numbered sequentially. Moving to the right, we can see the various fields that we use to define an attribute. First will be the name. Much like defining an element, we can also have a description and a category. Now for attributes, we have this checkbox for configuration item. When this box is checked, it means that new values for the attribute will be written back to the AF database. Therefore, it's important to only use the configuration item checkbox for user-defined constants or other metadata that does not change often. We would never want to have the configuration item checkbox checked for something like a PyPoint data reference, which gets frequent updates to its value. Moving further down the list, we see that we can define a default UOM for an attribute. It's important to note that AF can do automatic unit conversions, and the default UOM will tell us which unit you would like the value to be displayed in. Clicking on the drop-down, you can see the list of the large AF database of units of measure. Most of these are built in, but can also be defined by the user. Moving to the library, you can see that there's a unit of measures database, and here is where you can define your own units of measure or see all of the built-in units of measure that are already available. Moving back to our attribute, you can see we need to choose a value type. Some of the choices available are double or single precision floating point values, several types of integers, and also string values. Here I'll choose an integer. The value field can be used to define static values by the user. Finally is the data reference dropdown. In the next several videos, we'll discuss each type of data reference and how it can be defined. You can see that the data reference choices are none for static values, formula for calculated values, PyPoint to receive values from the PyData archive, string builder to perform string functions, and the table lookup to do SQL-style queries on user-defined tables. Here I'll simply choose none, and we'll define an attribute with a static value. I'll call this attribute zone number. I won't use a description because that's self-explanatory. Here, since it's just a number, it will have no default units of measure. It'll be an integer value. And for zone 1, I'll give it a value of 1. And I'll go ahead and check that in. Now we'll proceed to look at the other types of data references available to us.